All right, we're doing 6-2 angle bisectors, and we are going to be talking about theorems and solving problems about angle bisectors. So let's dive right in. You might recall that an angle bisector divides an angle into two congruent angles. That angle bisector could be a line, a segment, or a ray. So here is the first theorem. The angle bisector theorem is if a point is on the bisector of an angle. So we've got, let's see, I need a thinner one here. So here we've got our angle. And then we've got the bisector, BF. And then we've got a point. So here's our point here, right here at F. Okay. Then that point will be equidistant from the sides of the angle. And specifically, the closest distance. And so closest distance will be a 90-degree angle. So 90 there and a 90-degree angle there. These will be the same length. Okay, has to be perpendicular. All right, so if these angles are exactly the same, then those lengths will be the same. All right, so I hope that made sense. Let's look at that drawing again without me marking all over it. Okay, so if BF bisects the big angle, DBE, then and FD is perpendicular to BD and FE is perpendicular to BE, then we know that DF is equal to FE. So a lot has to happen there. These have to be equal and these have to be perpendicular. Now the converse is if we see this scenario, if we see that these are perpendicular and that these are equal, then we can prove that these are congruent, that we have angle bisectors. Okay? So we can go that backwards route. So let's go try it. This one says find QT in example 1. So let's take a look at what they've given us. They are showing us that these angles are the same. So we've got an angle bisector there in RT. Thank you. And they've shown us that these segments are perpendicular. And because of the angle bisector theorem, that means that these will be congruent. Okay. So RT is the angle bisector of angle QRS, and QT is equal to ST. Which means we can set them equal. 4x plus 8 equals 9x minus 7. And we will simplify that down to negative 5x equals negative 15. So x equals 3. And we were not solving for x, we were solving for QT. So we're going to plug x equals 3 back into QT. And we'll find that QT is 20 units long. All right. Hope that makes sense. Now let's go ahead and check that. You try it now. Here's your problem. Go ahead and take a minute and then pause me and try it. Right, did you get that SP was 17? Hope so. All right, now let's do the converse. Now they give us that this and this are both 5 long. So that means they are equal, and these are perpendicular, which then means, conversely, that this is an angle bisector, which should tell us that if this is 38, if XYW, angle XYW is 38, that angle WYZ must also be 38 degrees. And they're going to write that out more formally down here, and we'll fill in some blanks. So because those segments and lines are perpendicular, and WX is equal to WZ. W is equidistant from the sides. By the converse theorem, it is a bisector. So angle ZYW is congruent to angle XYW. The measures are also congruent because of the definition of congruent angles, and therefore it's equal to 38 degrees by substitution. Right. Now it's your turn. Tell me how big the measure of angle JKL is. I'll give you 5 seconds. Pause me if you need. Right. Did you come up with 37 degrees? Good job. All right, now we're going to talk about angle bisectors of triangles. And just like when we talked about perpendicular bisectors, angle bisectors also are a point of concurrency in a triangle. Because a triangle has 3 angles, it also has 3 angle bisectors. And the angle bisectors of a triangle are concurrent, and their point of concurrency is called the incenter of a triangle. The incenter. So this is kind of cool. So when they're drawn in, all 3 angle bisectors, they meet up at this point right here, the incenter. Okay? And then when you draw to the nearest point on each side at a 90 degree, and find this point, E, F, and D, these are all the same length. And if you think about that, them all being the same length, that means you could, let's see here, I've got my notability going, so this might actually work pretty well. I wonder if I can get it going. There we go. You can make an inscribed triangle using your incenter. That's kind of cool. There we go. Okay. You will be doing this in Alex. And I want you to see this. You will be making angle bisectors. Angle bisectors. You'll be making one over here like that, and another one over here like that, and finding this point. But then you will also need to be dropping a perpendicular line, okay? Then you'll be making a perpendicular line. Oh, I'm having a problem writing perpendicular line to find this point, because you will need the center of your circle. This is really big ink. I apologize, guys. And you will need the outside of your circle to be able to make that circle when you're doing your constructions. So there's a lot going on in here when you do this in Alex for your constructions. Sorry. So watch the video in the Alex topic to see it. There we go. That would be my advice. All right. I'm going to get rid of this, but I just wanted to give you that little extra hint there. Okay. So P is the incenter. So let's go see what that looks like. Oh, let's look here too. What things are equal? Okay, so this is equal to this is equal to that, right? okay? And we still have right triangles everywhere, right? We still have right triangles. We have equal angles everywhere, okay? But no more equal sides, like there's no more midpoints along the edges, no more congruent triangles. Or is there? Actually, look at this. This one would match itself, so this must be the same. Look at that. Oh, here's a congruent triangle right there. Okay. And then this would be a congruent triangle with this one. And this would, yeah, there we go. So let's see, this 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's a lot of colors. There we go. There's all the things that match. Wait. 7. Oof. Yeah. Okay. I wouldn't worry as much about the outside stuff. Worry about the angles. And remember that these all match. Okay. Let's go check out some. P is the in-center. And then it says find LZP. So let's mark that out. Where is LZP? Right there. This angle in here. Okay. They tell us that this is 24.6 up here. They tell us that this is 25.1 down there. They tell us that this is the in-center. Okay. And they do tell us some lengths. Okay. Okay. All right. Well, if it's an in-center, that means that these are all equal. That's equal to that. That's equal to that. And this is equal to this. So this one's 24.6. This one's 25.1. Okay, we're getting there. What we can do is we can look at it as a big whole triangle as Z, Y, X. And if this is 25.1 and 25.1, that means it's 50.2. And if these are 24.6 and 24.6, that means, well, 24 plus 24 is 48, 49.2. Which means how big is Z? And we grab our calculator. And we say 180 minus 49.2 minus 50.2. It's 80.6. So that means that it has to be split in half. So 40.3. So we can find those angles by thinking about it as a whole triangle too. All right, so that's what they're going to walk us through, just like that. So the first part was walking us through the 49.2 and the 50.2. And now there's the math they did, the 49.2 and the 50.2 added together. And that gets us to 80.6. And then they're going to half that and get us to the 40.3 degrees. There you go. Now notice what they also did to throw you off the scent, they threw in this 7.3 and that 5.6 to mess with your head. Don't let it throw you off. All right, now you go ahead and find the measure of angle JAC. Pause me, come check your answer. All right, did you find 27.6? Hope so.